everyone, it's Sandy Cottle. I hope all of y'all are doing well. We're going to start some series of lessons. If we haven't already, we may have already started this series, but on Chapter 2. And I'm going to be doing two videos on the organic and inorganic compounds, one on each one. Today's lesson is going to be on inorganic compounds and their importance in our body. There are four basic groups of inorganic compounds: acids, bases, salts, and water. Yes, I have it a little bit different order on there, but for some reason or other, that's the way I've always learned it. So you need to remember acids, bases, salts, and water. You're going to see that one of the things that these have in common is that they do not contain carbon. Let me get a different color. Except for carbon monoxide and carbon dioxide. I see the twos up, should be down here. Anyway, there is a very important relationship between these inorganic compounds, and that is because these molecules react in water. When you have an acid plus a base, you get a salt plus a water because of the ionization. Let me give you an example. An example would be hydrochloric acid, which is a real common acid in our body, especially in our stomach. And another common base would be sodium hydroxide, NaOH. When you have this acid and this base together, they react. And what happens is the chloride, when it ionizes, and the sodium, when it ionizes, they wind up liking each other and attracting to each other because the sodium becomes a positive ion, chloride a negative ion, and they wind up making NaCl. You know what that stands for? That's like the common name for, or the chemical name for salt, a table salt, for instance. And then your hydrogen from your hydrochloric acid and your hydroxide ion, hydrogen is a positive ion and OH is a negative ion. When they find each other, they're going to attract each other to form HOH, which is what you commonly know of as what? Put these two together, H2O. So there's a really important relationship between acids and bases and salts and water. That's one way to help you remember these four groups. An acid plus a base yields a salt plus water. We're going to take each one of these groups and talk about their importance in our body and some of their properties. The first one that we're going to talk about is water. It is the single most abundant compound in the body. It maintains about 60 to 80% of all the contents of our cells, and it has a lot of really unique properties. And I'm not going to go into them in a lot of detail, but I'll give you some examples of how these work. A property of water is that it actually absorbs and releases heat slowly. Where this is an important concept is its ability to help kind of stabilize our body temperature in a homeostatic range. Muscles are where our heat is generated primarily, and as our blood vessels, which blood is mostly water, as our blood vessels run through muscles, the blood is heated up, and since it's mostly water, it holds the heat. But then as it circulates to our body, to other parts of our body that doesn't have as much muscle action going on, therefore it's not creating as much heat, therefore it's cooler, then it allows the heat to dissipate and warm that environment. So this property of water, because it absorbs and releases heat slowly, makes it a real good radiator system for our body as blood is circulated through our body. Another thing that it's really good at is that it's a universal solvent. That just means that a lot of things can be dissolved in water. That's what a solvent is. We will talk specifically about how our electrolytes, some of our salts, for instance, are dissolved in water, and when they do, they ionize, like I mentioned in that example a minute ago. Another thing that's so important about water is it is a very important reaction in a lot of chemical reactions. It is important in those chemical reactions. Almost everything that we do in our body requires some water for the reaction to take place. Again, it has a lot to do with the fact that it's a solvent. Another thing you're going to see that water does is it provides a really good cushion. An example would be our synovial joints, which are the joints that have synovial fluid in them that are freely movable, and the fluid acts as a lubricant. A different example would be bursa in the joints. Your bursa are little bags of fluid that help absorb the shock as you push on it one direction or another. Another example would be amniotic fluid that is found in the uterus when a mother is pregnant, and that fluid, of course, provides a very good environment that absorbs shocks and protects the baby, so it cushions the organs that way. You're going to hear so much about the fluid electrolyte balance, and I'm going to be referring you to my A&P place at the end of this to do two major things. There's some really good interactive physiologies, especially the introductory right now. It's the main thing you need to be thinking about on the water balance in the body. And so I will refer you to that in just a minute, and I want you to go to my A&P place and actually watch these after you watch this particular video. Let's go to the next and talk about salts, because this is the other side of the fluid electrolyte balance. The salts form our electrolytes in our body. Lots of things they do. Salts are ionic compounds that dissolve in water, just like the NaCl ionizes in the water. It contains cations other than hydrogen. Cations are the proper name for your positive ions. And anions, think an being to take away from or negative. Anions are your negative ions. But notice that we say other than hydrogen and other than hydroxide because our acids and bases are going to ionize to release hydrogen cations or hydroxyl anions. The salts release other positive and negative ions that are not the hydrogen or the hydroxide ions. Some examples. We've already done an example with sodium chloride. Calcium carbonate is another example of real important one you're going to talk about a lot in the body. Potassium chloride is another one that we have in our body, and calcium phosphate is another example of some of the salts in our body. Function. Sodium, potassium, calcium chloride, phosphate, magnesium, etc. Some of these are going to be really, really important in generating impulses to make muscles contract. The impulses, of course, are going to be how ions are distributed along an axon of a neuron, a nerve cell, and those ions are going to be allowed to swap out, which generates what we call an action potential. You know of it as an impulse, and you absolutely have to have your electrolytes set up in a very particular way with using what we call the sodium-potassium pump, for instance, before you can even send an impulse. And then the muscle cell that's going to respond to that impulse also has to have its ions in a very particular arrangement in order to receive the signal. So it's going to be really important in that. We'll talk a lot more about this as the semester proceeds. These minerals also contribute to the hardness of bones and teeth, primarily because these organs are simply storage facilities. As we take in food that's got these particular electrolytes in them, if we have an excess, they're going to be stored in our bones and maybe even our teeth until we have a use for them, which is almost constant. But when you're not taking any of these things in, then you're able to pull from your storage facility, your bones, when you do need these molecules to perform other functions. Like, for instance, calcium is going to be another ion or electrolyte. It's going to be really important in muscle contraction. We will talk about that a lot later. So when we use a lot of calcium during a muscle contraction, we're pulling it out of the bones. And that kind of disturbs our homeostasis of that until we get more calcium in by way of our diet and can replace the storage of that ion in our bones. And then, of course, we continue to use it. So it's very much like stocking up your shelves in your kitchen from going to the grocery store, and then you use things off the shelf until you've gotten your supply depleted, and then you go back to your grocery store and restock your shelves. And it's kind of the same thing with the bones and a lot of these electrolytes. Another real important function of the salts are that often these electrolytes function as coenzymes, and coenzymes are simply factors that are needed to help make a reaction proceed. Of course, an enzyme, you're going to probably hear more about that in another video, but an enzyme is basically something that helps a reaction proceed, finish, get it started, speed it up, or even it could stop it. But an enzyme is needed for a reaction to happen sometimes, and a coenzyme might just be a factor that actually is modulating that particular reaction also. Okay, again, this is the electrolyte half. Salts are the electrolyte half of the fluid-electrolyte balance that's so important in our body. At the end of this video, and I keep referring to you to do this, I want you to go to my A&P place and look for the interactive physiologies and look for introduction to body fluids. At the end of all this, I will actually point out the specific ones that I want you to do. But the interaction of body fluids will help you understand your water balance and how electrolytes are important in the body. Let's go on to acids. Remember, we had acids and bases and salts and water. Acids also ionize and dissociate in water, but when they ionize, they are creating a lot of hydrogen ions, and these are anions, hydrogen ions are cations, they're a positive ion, but the other half of the acid, what it's releasing is the negative ions that are with it. For instance, hydrochloric acid, here, when these split up, when it's in water, then hydrogen ion is this ion, and the anion, when they split up, would be your chloride ion here, the negatively charged particle. Another real important, well, let me stop and tell you about hydrochloric acid. Hydrochloric acid, for instance, is primarily found in our stomachs, and the whole purpose is to try to set the environment so that the enzymes that are in our stomachs that begin protein digestion so that they can be activated. Without this really low pH that you get with hydrochloric acid, the enzyme would not do its job. We will be talking later in the semester and even in 202 about your acid-base balance and how important it is. We're going to be talking about imbalances such as your body going into alkalosis or acidosis. To take that one step further, for instance, if you were vomiting and you vomited up a lot of your stomach acids, that could throw off your whole pH balance overall in your body, and since you're getting rid of the acids, you might go into an alkalosis state. And then later down the road, I know you've probably heard that we classify acidosis and alkalosis as either being respiratory in nature or metabolic in nature, and you'll learn more about that later. Carbonic acid is another really important acid that you'll hear a lot about as we study it. Carbonic acid is created as CO2, which is a waste. You know, carbon dioxide is a waste from our cell respiration process. When it mixes with water, which is found in our blood. For instance, the cells that are going through cell respiration to create ATP, the energy we need. When we get rid of the carbons that came from the glucose molecule, they are released as carbon dioxide into our blood. That then is mixed with the water in the blood, and these two together create carbonic acid. So, for example, if you're exercising a lot, you may be creating a lot of carbon dioxide waste because you need a lot of energy to exercise. As you create more carbon dioxide waste, you may be creating more carbonic acid in the blood, which would throw the blood into an acidosis state if you didn't have a buffer, which is a base, that to try to keep it in balance. So again, these molecules are really important in something we call acid-base balance. Let's talk just a minute about the bases now. The bases ionize and dissociate in water also. But when they ionize, they create more hydroxyl ions, OH ions, than they do hydrogen ions. These most common bases in our body are the ones that form hydroxides. The bicarbine is a really important buffering mechanism that's primarily coming from our pancreas, and it helps to raise the pH of the hydrochloric acid that was in our stomach. When that content of the stomach moves down into the next section, the duodenum of your small intestine, you're going to have to try to neutralize the acid from the stomach before the next series of enzymes can do their job. These are called buffers, and the bicarbine is secreted into the duodenum from the pancreas, and that's its main job, to try to buffer or to raise the pH so that the next set of enzymes are more effective. The ammonia ion is also going to be a real important ion that we'll be talking about, and we'll talk about how important the kidney is in getting rid of the nitrogenous waste. Ammonia is an NH3 or NH4 molecule, and that's one of the reasons why urine smells like ammonia, is that our kidneys are filtering out the nitrogenous waste that basically come from, if you remember, I did this video earlier for you, but nitrogenous waste comes primarily from what two compounds, you remember? Or that may be coming in the organic one that's next. You may not have had this yet, but the nitrogenous waste comes from the protein breakdown in our body and from nucleic acid breakdown, DNA and RNA that's in every cell that we eat. So, again, I'm going to be referring you to the interactive physiology on the acid-base balance. Let's take just a second before we do that, though, and let's talk about what pH is. pH is simply a measure of the concentration of hydrogen ions in solution. And the scale typically runs from 0 to 14 when you're kind of measuring any general pH of anything, any solution. I like to write it a lot of times in a horizontal way. And you probably know already what neutral is. What is neutral on the pH scale? Be right in the center between these two, and it would be 7. And that's in general chemistry. Our body has specific ranges of pH that are normal, that may be shifted one way or the other from this particular thing. For instance, hydrochloric acid, I'm going to show you something in just a second, but hydrochloric acid is down around 2. But basically, the main thing I want you to get here is the lower the number, the more acidic the substance is. That also means that it's releasing more hydrogen ions in solution when it's in the water. The higher the number, even if your scale is a near scale, think low and high on the number, the higher the number, the more alkaline or basic the substance is, and on this case it's releasing less hydrogen and more hydroxyl ions in solution. Okay? Now, let's go to a picture right out of your textbook that shows you some compounds that you normally run into, and this whole range. Here is the scale written in a vertical way. Here's your 0, here's your 7, here's 14. Remember, as you approach a lower number, the substance is more what? Acidic. So increasingly acidic is going down this way. Here they've got hydrochloric acid could be as low as a 2, although stomach contents sometimes are around, they've got hydrochloric acid as a 0. Stomach contents may be around 2. Lemon juice, here's gastric. Notice lemon juice, which is similar to gastric juice, there's your pH of 2. So our hydrochloric acid is not as strong as, say, hydrochloric acid you'd find in the chem lab. It's 1 molar. Coffee is slightly acidic. Look at blood. Actually, a homeostatic range for blood pH is going to be 7.35 to 7.45, where if you are lower than that, you are going into acidosis. If you are higher than 7.45, you're going into alkalosis. So you're going to hear a lot more about this. Egg white, notice it's an A. Household bleach is a basic. It's an alkaline substance. Ammonia, household ammonia is alkaline. Oven cleaner, really alkaline, which is approaching here 14, which is 1 molar solution of sodium hydroxide, is an example of a really strong base. So we're ranging here from a really strong acid to a really strong base, and then you get some ideas of the different compounds you have around your house that have that in them. Don't worry about this scale over here, but what they're trying to impress on you on this scale here is that for every change in your pH, every number change in your pH is a logarithmic number of hydrogen ions that are released. So there's a lot of 10 times more from one to another hydrogen ions to the power. See how you're going from 10 to the 8th power, 10 to the 9th power, and so forth on here. All right. I think I have one last slide, and this is where I am referring you to go to my A&P place. I'm going to show you how to get there. But you're looking primarily for the interactive physiology. These are great little videos. They have a lot of animations in them, and they give a lot of examples, and you have to click and drag, and you have to do a lot of interactive things. But the beginnings of these are going to really help you understand the fluid electrolyte and the acid-base balance. So when you do you're going to want to do two. Remember, you're going to do some on the introduction to body fluids, and then I want you to do at least pages 1 through 12 on the acid-base homeostasis, also page 16 and 17. So you might want to write those pages down. Now, if I can take just a second to go to my internet, let me see if I can log in here to the internet. I don't know if it's going to let me pause. Okay, I hope you can see this. This is just like your Blackboard account, the home page on your Blackboard account. If you are looking over here at the left, when you get down to coursework, you will see this icon that says My A&P Place. I want you to click on it. Go to it by clicking on it. You may need to log in. Find the textbook that we're using, which is this one. I'm going to log in just to show you. I'm not sure that's the right login. Hang on just a second. See if I can get into it. Hello? Okay, still working. Just taking a moment to load, so just be patient. It's still trying to do it. Should not take this long at home, you guys. I'm going to pause the recording while Okay, when you get to this page, I suggest that you go, over here on the left-hand side. You see this menu over here? Go to Interactive Physiology. Hurry up and wait. Okay, once you're in interactive physiology, here's a list of all of them. There's quite a few of them with this textbook, and you'll notice fluid electrolyte, acid base is down here. There is a link to one of them in Chapter 2. And I'm going to show you the ones I want you to go to, if it'll ever call it up again. So we're going to go there. Okay, I think the next thing will be that you will see this topic. It says fluid electrolyte to acid-base balance, introduction to body fluids. Now that's the first one I want you to go through. And this is what it's going to look like.
The fluids in your body are composed of water and dissolved substances, including electrolytes.
Okay, I want you to go through this whole thing. So you will go page through it. Be sure that you watch everything on there and don't get ahead of it. I'm going to
electrolytes in the body to identify the fluid compartments.
I can't
and the
quieten it down. So you're going to go through each page. Watch the example.
Through the gastrointestinal tract. To see the movement of fluids through the gastrointestinal tract, drag the glass of water to the figure's mouth.
All right, now I'm going to cut it off here.
Into the plasma in the intestines. The fluid search.
All right, I want you to watch that whole thing. Did you notice how I went and clicked home up at the top? When you do, you get this whole list of all of the IP physiologies. You can click on fluid electrolytes. The one we were just in is this one called Introduction to Body Fluids. And then the other thing you want to watch at least some of, remember I referred you to a few pages. Let me go back and find them. 1 through 12, 16, and 17. At least do those pages on this one.
Chemical buffers, the respiratory system, and the urinary system work together to ensure that the pH of body fluids remain within a specific narrow limit.
You want to do all 12 of these pages plus page 16 and 17 at least. You might want to see more than that. But notice here's where I was when we were into that first one, and then we went back home, and you got the list of all of them there. So I'm just trying to show you how to get to everything. These are wonderful. We all strongly recommend them. They will help you understand. Fluid electrolyte, acid-base balance are some of the hardest concepts for students to get used to, especially when we only introduced them once years ago. Now what we're doing and what was advised to us to do from the allied health field is that we need to start introducing these things immediately. So we're starting in 201, and you will hear all about fluid electrolyte and acid-base balance from now to the end of 202. And if you get in nursing school or some of these other health programs, you will be learning a lot more about them, and I hope we give you a really strong background by the time you get through 2 semesters of trying to understand this stuff. In the meantime, I hope you have a good evening, day, whatever it is, and I will see you next time. Bye.